tomorrow's class. That entire topic, there are two classes aligned on it. So don't worry about it, guys. We'll definitely be covering it. Now, apart from that, right, guys, today we'll be solving a lot of problems on interactive problems. And the thing I want you all to realize is that interactive problems is just a different type of getting input and output. Apart from that, whatever you need to solve interactive problems is just problem solving. Okay. If we just keep implementation away for 1 second, then solving interactive problems is not actually that hard, apart from the input output thing. Okay. So we are going to discuss three problems today, and let's have a look how interactive problems are solved. So let's start with the first problem, guys, right? This is problem one. Let me share. It's not really true, Priyansh. Like, it depends on the problem. Today, I have a problem which is not based on binary search and randomization. But yes, there are quite a few problems on interactive problems that are based on binary search and randomization, right? It's not always true. So let me just share the link of this problem in the chat. Okay. And let's have a look of how to solve this. So guys, what does the problem say? First of all, it's an interactive problem. Second thing, there is an array and Horner wants to play a game with you, right? He has hidden a permutation A1, A2 up till AN. What is a permutation, guys? It's an array with elements 1 to n appearing exactly once, right? You are asked to find any index k which is a local minimum. For an array A1, A2, AN, an index I is said to be local minimum if for a for AI it is smaller than minimum of AI minus 1 and AI plus 1, right? And now, okay, all of that is done. Now, what can you query? You are allowed to choose any index I and make a query with it. As a response, you will get the value of AI. You are asked to find index k and you are allowed to do 100 queries. Is the question clear, guys, for everyone? Basically, we are asked to find the local minimum of the array. And for each query, we can query any index and we will get the value of the array. Is this clear with everyone, guys? Okay. So if this much n is smaller than equal to 10 raised to 5, if I'm not wrong, right? Yeah, it's 10 raised to 5. Okay. So yes, like majority people were able to come up with the solution right away. So guys, we are given an array, right? Now our task is to find any index I such that AI is smaller than AI minus 1 and AI is smaller than AI plus 1. Okay. This is what we are supposed to find. Now, guys, how do we go about solving this? Because we can do only 100 queries, right? So what do we do? How do we come up with the intuition? What will be required? And how do we go about solving it? Right? Yes, if I is equal to 0, you can consider that there is infinity on both sides, right? This is the minus 1th index and this is the nth index. You can consider that there is infinity on both sides. Okay. Now, guys, The first thing that I want you all to notice is that this is a permutation. Okay. Now, what happens when this is a permutation, guys, right? When it is a permutation, no two elements are the same. No two elements are the same, right? Now tell me, guys, if no two elements are no, you haven't missed anything much. We have just started out with the problem solving session, right? Since no two elements are the same, can I say that for any index I, guys, either AI is smaller than AI plus 1 or AI is greater than AI plus 1? Yes or no? Tell me. Yes? Is this clear for everyone, guys? Okay. Now, if this much is clear for everyone, this is more or less our first observation. I'm trying to bring up the intuition of how we can solve this problem, right? So, this is our first observation, that since it is a permutation, I have shared the problem in the chat below. Like I've shared it earlier. Okay. Now, guys, this is our first observation. Now, how can we use this observation to come up with another observation, right? Now, guys, what is the second observation? Let's say you are on index I, right? And there can be two cases. Either AI is smaller than AI plus 1 or AI is greater than AI plus 1. Yes or no, guys? Tell me. Yes? Okay. Now, let's consider that AI is smaller than AI plus 1 and AI is greater than AI plus 1. What will happen? Okay. Let's consider this first, Priyans, then we'll get to AI minus 1 as well. Okay. So, guys, when AI is smaller than AI plus 1, right? What does this mean? This means that this is AI plus 1. Let's say this is 5. This is 4. Now, if this value, whatever is AI minus 1, it can either be greater than AI or smaller than AI. If this is 5 or 7 or something like that, again, this is our local minimum. Yes or no, guys? Okay. But if this is also smaller than 4, okay, this is the only other condition, right? This can be 3. Do you agree that the local minimum will exist somewhere in the left? Yes or no, guys? Because the numbers are decreasing, and worst case, the numbers decrease up to the 0th index. Okay, it's like 1, 2, 3, 4, 5. In this case, this is the local minimum because we are said to consider the minus 1th index as infinity. No, the array is not sorted. Anush. The array is not sorted. Right? So, is this clear with everyone, guys? When AI is smaller than AI plus 1, we can more or less say, right? Let's say this is my index I. I can say that the local minimum lies over here. Yes or no? Local minimum has to lie here. There can be multiple ones. Okay. Why couldn't See, maybe it is there on the right hand side. I don't know. But what am I sure about is it is there on the left hand side, right? It might be there on the right hand side. Okay. But am I sure about it? No. What am I sure about, guys? I am sure that it lies here. Yes or no, guys? Tell me. Yes? Okay. Now, similarly, guys, can you tell me what is going to happen when I am at I and AI is greater than AI plus 1? Can I say that my local minimum, right? That my local minimum does lie on this half? Yes or no, guys? Because this is going to be a chain where AI is smaller than AI plus 1. It is going to continue up till a point and then it will break. And that is exactly my point where my local minimum is. Can you repeat why not on the left hand side? I am never saying that the local minimum might not exist, will not exist on the left hand side. It very well might, but an array can have multiple local minimums, right, guys? Let me show you with an example. Okay.
Like
Consider the, yes, tell me.
what if the array is sorted till I plus 1?
So you're
In the
saying
first
one,
case, in
two,
the
three,
first case,
four,
yes.
five. Yeah.
In the first case, yes.
Yes. Consider this is I. So here AI is smaller than AI plus 1, right? So I can say that the
Yes.
local minimum lies in this range, right?
But no local minimum there, right?
No, 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 no. The problem says, right, that you can consider the minus one element and nth element to be infinity. So the array
Oh,
is
yes, yes, yes.
technically
Yes, yes.
this.
Yes, sorry, sorry.
So this is my local minimum, right? Keep this in mind, right? Okay. Now, guys, getting back to the question. First of all, an array can have multiple local minimums. Consider something like 3, 1, 2, and then you can consider something like uh, 6, 4, 5. Do you see that my 1 is a local minimum and a 4 is also a local minimum, right? Now, consider my I is here, right? My I is this. So AI is greater than AI plus 1. Do you agree that these numbers are going to keep decreasing up to a point and after that it will start increasing? And basically, what can I say? I can say that my local minimum would lie on the right hand side. It might lie on the left hand side, and it does, right? But what am I sure about? Am I sure that it lies on the left hand side or does it lie on the right hand side? What information did I get, guys? Tell me. Yes, I is the query index. Yes. If you look at it, if AI is greater than AI plus 1, then it forms like a slope till one particular index j, AI is going to be greater than AI plus 1. And after j, AI is going to be smaller than AI plus 1. And this right here is my local minima. But we have to return one of the local minimas present in the array. Yes, exactly, Krish. Okay. So, guys, is this much clear for anyone? Sakshi says, but array could have been 654. Yes. So, 4 would have been our local minima, right? If the array would have been 654, 654. Do you see that this right here is my local minima. Okay. So guys, is this observation clear? That if I query an index, depending upon what relation it has with I plus 1, I can be sure about which side I want to query. Yes or no, guys? Tell me. Okay. So, what can I notice? I can notice that if I query I am either discarding one side of the array or I'm discarding the other side of the array. Basically, what I'm doing is I am discarding one part of the array. Yes or no, guys? Yeah, we can have many queries at a time. We'll get to that, right? If someone has any doubts, feel free to ask. What if the array is 2, 3, 4, 1, 5? 2, 3, 4, 1, 5. In this case, you have your local minima here as well as here, right? Yeah, so the local minima is this. Push it. Okay.
Sir.
Yes.
Sir, what if the question was like print all the local minimas? Then obviously it's O of n only, right? There's no other chance.
Yes. Yes.
Okay, sir.
Okay. Because there can be O of n local minimas in the array. As you can see, for every 3 elements, we can have one local minima. Okay. So guys, now that we can notice that we can discard one part of the array, what idea can we use? We want to discard as many elements as we can on each iteration. So what comes to mind, guys? Doesn't binary search come to mind? Like, it is not technically binary search, like, but we can use the same idea here, guys. And how do we do this? Let's have a look. Okay. Consider that I have my array. Let me take the same array that I took, right? 3, 1, 2, and 6, 5, 4. Okay. Now, let me binary search on this. And how are we going to binary search on this? Let's have a look. Since we are allowed to do 100 queries, okay, and we are doing binary search, how many iterations does binary search take, guys? Log n, right? Now, what is log of 10 raised to 5? It is around 16 or 17. Okay. Now, I can do around 4 queries per iteration and I would still be okay. Yes or no, guys? Tell me. Yes. So, what will I do? I start with the entire array. And if I have a mid, okay, currently this is my mid, I will query mid. I will query mid minus 1 and I will query mid plus 1. Okay. Now, if this is a local minima already, I can just print mid. Yes or no, guys? Tell me. Okay. Now, if this is not the local minima, I can go in two directions. Either, now what are the cases? ARR mid minus 1 smaller than ARR mid, or ARR mid plus 1 smaller than ARR mid. These are the two conditions that are going to happen, right? Both can happen at the same time. But one of these conditions is definitely going to be true. Yes or no, guys? Tell me. Yes? So what do I do? I can, yes. So if this is the quiz, if ARR mid minus 1 is smaller than mid, I can say that my answer lies in this range, right? Which is actually true. So I can just make my search space equal to this. Left, what I'm trying to do is right is equal to mid minus 1. But if the other one is true, then I can just go to right and say is left is equal to mid plus 1. If both are true, you can choose whichever direction you want to go. Is this clear for everyone, guys?
Uh, Here we can make like only one query, right? Say example, we find the first query useful, we can go in that direction continuously until we reach a point. Or if the first query isn't true, then obviously it's the second one. Maybe can we do that in two queries as well?
But worst case, it would take me, yeah, you can do that in two queries as well. Yes.
Yeah,
If
at
you
one
want,
point you'll definitely reach the minima, and then
yes. Like, you can do it in two queries if you want. Like, either you can query only mid and mid plus 1, or you can query mid minus 1 and mid. But since the constraints allow us to do three queries at a time, it's just easier to do it. And for checking if something is a local minima or not, you will have to do three queries. Yes or no?
say example we reach the minima at one point, then we break out, and then we can check.
Yes, but how will you check if something is a minima or not? You will have to do three queries, right? So on average, you worst case you would be doing three queries, right? For example, you query mid and mid plus 1. So you can see that this is greater than this. Okay. So you are saying you'll set your answer to this index and then move towards the left.
Yes,
Okay, you can do that as well. You can do it in two queries. Yes.
we can maintain previous states like uh, until we reach a minima. Say example, once we reach one, we can break out, and this will be our point.
Yes, we can do it in two queries as well. That also works.
Yeah.
Okay. So guys, there are many approaches to it, and yes, you can do it in two queries as well. Just for making this simpler, I did it in three queries. It's up to you. If you can do it in two queries, feel free to do it. Okay. So guys, getting back to the question, we saw that we reduced the search space to this much. Okay. Now again, we'll do the same thing. We'll query three and we'll query mid minus 1 and mid plus 1. Now mid minus 1 is zeroth element, so it is infinity. This we'll handle on our own. And this right here is minus 1. Okay. Do you guys agree that now this case is what we are we are on? Mid plus 1 is smaller than ARR mid. So what will I do? I will just break, I will set my left to mid plus 1. And now you can see that I have only one element, right? And now when I query this, you will see that this indeed is the local minima. And then I will just print this. Is this clear for everyone, guys? Clear? So in each iteration, what am I doing? I'm starting with left is equal to 0, right is equal to n minus 1. And my idea is just to binary search, right? And since we are doing binary search, we would be doing three or two queries at a time. It's up to you. And since binary search would be 17 iterations, the maximum number of queries would be 3 into 17. And this is much smaller than 100. Yes or no, guys? Clear for everyone? Yes, 51 queries at each. Okay. So tell me, guys, wasn't this just a normal problem? I'll show the implementation right now, but before that, is there anything special about interactive problems as such? No, right? It's only the implementation, right? Yes. So this is the last slide. Chris said, I'll just show it for a minute. Uh, what will query return if I is equal to 0 and I is equal to n? Let's have a look what the problem says, right? And if it does not, we can just handle it by ourselves. If mid minus 1 is 0, then I can just return infinity. Okay. So yeah, I can choose 1 to n as well. So I have to handle it on our. So Mandar says debugging interactive problems seem difficult. Uh, if you solve it, yeah, exactly. We'll not send it to the judge itself. So guys, now how do you code out interactive problems is what we need to know. Okay. Let me just erase this and give you some tips on coding out interactive problems. Okay. Right. So guys, for interactive problems, okay, first of all, you have some choices. Either you can write a validator yourself or you don't. I personally don't do it. Right? How do we test? I'll show you in a bit. Right? Okay. So now, guys, for interactive problems, first of all, write a query function. Okay. And what does the query function do, guys? Query function takes in ln or whatever you want to query. Now you see out this here, right? You see out this lr here. You take an input from the judge. Cn input and then you return it. Okay. This is much better than writing it in code itself. Okay. Um, what are interactive problems? Interactive problems where you are interacting with the judge. Basically, you are just given something that is hidden. You need to find it out. And you can do that by asking questions to the judge. Okay. Now, what is important is that you have to write this endl, because if you're using fast IO or all those means, what does \n do? It does not print out all the output one by one. It prints it all at once at the end of the program. So to avoid that or to flush the output, we write endl. So exactly when in my code I do cout, that is the exact time it gets printed. Okay. This is to flush our output. Now, guys, let me show you the code. Right now, the code is very simple. Okay, you can have an answer variable as well. Okay, so first of all, you see that I have a query element, query function. Okay, and in my query function, to simplify my code, what am I doing? I am having a whatever I'm expected to print, I'm printing that. I'm taking an input and I'm returning this input. So I don't need to write this query again and again in my code. Is this clear for everyone, guys? Tell me. Yes or no? Yes? Yes? Okay. So if this much is clear, after this, I'm just doing by normal binary search. And how do you do binary search, guys? You can just implement it as it is. Why left smaller than equal to right? I'm having mid outside, okay? I'm just having mid or answer as a variable. Mid is left plus right divided by 2. Now I'm querying all three elements, mid minus 1, and mid plus 1. Now if mid minus 1 is 0, okay, if mid minus 1 is equal to 0, or mid plus 1 is equal to n plus 1, in that case, I am having 1e9. And after that, I am having query mid minus 1 and query mid plus 1. Do we need to write cout.flush to avoid idleness limit exceeded? You can do that, but you can also just do it using endl. Because what endl does is it flushes the output. Okay, let me zoom in. Yes. Okay. So guys, if a mid minus 1 is 0, then the left element is infinite. Otherwise, it's query mid minus 1. What is my current element? It is query mid. And what is my next element? If mid plus 1 is n plus 1, then it's infinite, or it's query mid plus 1. Now, if A is greater than B and C is also greater than B, what does this mean? This means that mid is the local minima. Yes or no, guys? So I can just print this. Otherwise, if A is greater than B, then I go to the right hand side, right? Otherwise, I go to the left hand side. That is all that I'm doing, guys. And can you show the query function? Sure. It takes in the index, it prints out that particular index, it takes in the input, and it returns that input. This is a very good practice to do, because then you can focus on what you have to implement and not write this code again and again. Okay, it's a very good practice to have this query function in interactive problems. Now, someone was asking, how do you test this? So to test interactive problems, you try to have some input in mind. Okay. So, for example, as I said, you have 6, 3, 2, whatever, right? After that, you run your program. Keep in mind that you have to run this on terminal. So once you run your program, you will have to provide input as a judge and see if for the test case you came up with, is your code able to come up with the solution or not? Yes or no, guys? Tell me. Okay. Implementation is not that hard. The only thing we have to, yes, exactly. You have to think of a test case in your mind. That is the only challenging part of an interactive problem. Think of a test case, think of the answer, and see if your code is able to come up with your answer. If your code is giving wrong answer, try to think of more test cases and then test for those test cases that is your interactive problem, interactive code able to solve it or not. You can also write your own validator, but I just do that in terminal. Okay, so how to cover edge cases? That is what your debugging skills will come into play. Like in majority of interactive problems, if your code is not working, then you would have to debug your solution, see where it fails. It's same as a simple problem, right? Even if in a normal problem, your code is failing on pretest 2, you would still have to debug it. Similarly here, if it's failing on pretest 2 or something like that, still have to debug it. But apart from that, there is nothing special about interactive problems. And that is what I wanted to convey using the problem story.
Hi, Gorish.
Yes.
Uh, can you just repeat the process where you came up with the intuition? Because I joined a little late. I have understood the question. I don't have any doubts. Just wanted to, like, how did you come to the intuition of the problem?
Right. So it's, so Abhiram says why it's 1700? Because I don't know, like it wasn't that hard, right? I think coming up with binary search is the hard part here. Like coming up with the intuition is not the easy part. So first observation that we made is since it's a permutation, all elements are different. Now, since all elements are different, what can we notice? We can notice that one of these conditions have to be true for every I. Either AI is smaller than AI plus 1 or AI is greater than AI plus 1. Okay. Now, using this intuition, you can break down your code into, now you can see what happens. If AI is smaller than AI plus 1, you can say that the local minima lies towards the left. Otherwise, if AI is greater than AI plus 1, you can say that the local minima lies towards the right. Now, using just this observation, you can come up with this observation, and using this observation, you can say that you can use binaries first to solve the problem. Is that clear?
Yes, yes.
Okay.
Thank you, guys.
So, if this much is clear, guys, okay. Now, no. I don't write a validator, but you could, like, if if you're getting wrong answer a lot of times, you could consider writing a custom validator. Okay. Now, guys, moving on to the next problem. Now, this is one of my favorite problems because it breaks the meta, right? That it's only binary search or randomness problems. It's not that. Interactive problems are just problems where you interact with the judge. They're just normal problems, right? We are going to discuss 3 problems today. Okay. So, guys, this problem is called find a mine. Okay. Some of you might have gone through it. I'm not sure. It's a relatively newer problem. Okay. What does the problem say, guys? You are given a grid with n rows and m columns. The coordinates x, y represent the cell on the grid, where x is the row number from the top and y is the column number. It is guaranteed that there are exactly 2 mines in the grid at distinct cells. Okay. Denoted as x1, y1 and x2, y2. You are allowed to make no more than 4 queries to the judge, and after these queries, you have to provide the location of one of the mines. Okay. In each query, you can choose any grid x, y and return. You will get the minimum Manhattan distance from both mines to the chosen cell. Basically, you will return, what will you get returned? You will get minimum of x, x1 plus y, y1, comma, absolute x minus x2 plus y minus y2. Your task is to determine one of the mines after making the queries. Okay. So what does the problem say, guys? Let me explain it to you all. Constraints can be anything. Let's have a look. Okay. Constraints is 10 raised to 8 or 10 raised to 9. Okay. And m is 10 raised to 8. Yes, let me share the link as well. Okay. So, guys, let's have a look. So, what does this problem say? This problem says that you are given a grid. Okay. Let me draw a random grid which is made of n rows, right? And m columns. And on this grid, you have been given 2 random mines. You don't know where they are. You can ask 4 queries. Okay. On each query, you can ask a cell. Let's say you ask this cell. Then you would be given the minimum distance of the mine from this cell. So, for example, this cell right here is 1, 2, 3, distance 3 away. Okay. And another one is 1, 2, 3 away again. So what is minimum of 3 comma 3? It is 3, right? So if you query this particular cell, which is 1, 2, 1, 2, which is 2 comma 2, you would be returned 3. And using 4 such queries, you have to return the cell number of one of the mines. Is this clear, guys? Okay. So again, how do you go about solving this problem? Uh, no, we would need 4. How would you do it in 2 queries?
Sir,
Yes.
can we apply binary search on rows or either columns?
But how would you do it in 4 queries? That's log n, right?
Okay.
That's 10 raised to 8, that's around 60. Okay. So guys, the thing is that here we can do only 4 queries. Okay. So we need some sort of puzzle solving intuition. Okay, people are saying, give us time. Okay, I'll give you 5 minutes to think around this. Does everyone need time or should I proceed with the solution?
5 minutes, sir.
Okay. So think around it for 5 minutes. I'll get back at 2:20. If you have the answer, please refrain from putting it in the chat. We'll start discussing at 2:20, and that is when we'll discuss around the same. Okay. So I'll put the problem here, and you guys can feel free to think around the problem for 5 minutes, and we'll get back for 5 minutes.
Yes.
Okay, guys. So let's look at,
Sir,
yes.
sir, I have an approach like just tell me it's similar or like that.
Okay.
So, so what we have to do is if we pick a random x comma y in the
Yes.
grid, so like we check it by increasing x, and once we check it by increasing or decreasing y. If we check by increasing x and we get to know that there is actually not much change in the like distance we get, then we
Okay.
can say that something like that, sir. Like if you're getting that.
Uh, Gaurish, even I have an approach.
There are some issues with your approach. Whoever mentioned that right now, I'll discuss that in a bit. Okay.
What
Yes.
Uh, yeah, Gaurish,
Yes.
even I have an approach. Can I discuss it with you?
Yes.
So, I will go to the middlemost cell. It's in
Okay.
random cell which I picked. So first I'll query if that's correct answer or not. So
Okay.
and then I'll get the distance of both the mines. I'll get the
Wo-
distance of x coordinate and y coordinate. So
You, how will you get it in how will you get it in one query?
so no, I'll ask about the middle element, right? So they'll
So
tell me
you'll
the
ask,
distance.
you'll ask this and you'll get one as the answer.
Yeah.
So now
So
there are four possibilities, right? One, two,
yeah. There
three.
are four possibilities.
Yes.
So now I'll get one. So what I'll do is I'll add that to my x coordinate and then I'll query and then also I'll get some value. Suppose if I get two, if I go to the wrong side, I'll get two, right? If I go to the correct side, then I'll get the answer.
Okay.
I mean, kind of something like this. What I was thinking.
Okay. Yes. I think you could do that as well. That is an approach. You can definitely try it. I think it would work.
Yeah, thanks.
I think that works as well. Great. So, guys, let's look at how to solve this problem. Okay. Now, whenever we are solving a problem, despite if it is interactive or not, we always want to solve it using first principles, right? First principles problem solving. What I mean by this is we try to break, we try to point out the most obvious things, and then build our solution around that, right? Now, how can we easily do that for this particular problem? Let's have a look, right? So, guys, what does Manhattan distance actually give us? Okay. If we query this particular cell, okay, and let's say we get 2. What does this mean, guys? What does this mean? This means that either our mind could be here, or here, or here, or here, or these points as well. Is this clear with everyone, guys? We form a diagonal. Okay. This is what Manhattan distance means. Now, we want to get as less points as possible. Yes or no, guys? This right now gives me too many points. So how can I minimize that? Like here I can go in 4 directions, right? Which I don't really want to do. How can I minimize this? Exactly. I corner point. And now let's see what happens when I query a corner point. Okay. When I query a corner point, guys, okay, let's query 1, 1. Okay. When I query this 1, 1, let's say I get 3. Do you agree that my mind is going to be on this diagonal only? Yes or no, guys? Since it is 3, my diagonal is going to be on this query, this only, right? Yes or no, guys? Tell me. Okay. Now, I know that it is going to lie on this diagonal. Priyan says, how you got the intuition of querying a corner instead of a middle point? Very simple. Like I came to know that this forms a square, right? And like square or diamond shape. The thing is, I want now these are 4 directions, and it's very hard to come up with something that works in 4 directions. Now, someone suggested something that might work out actually, but when you're thinking, you just want to avoid this. And how can you avoid this? If you query a corner point, okay, these parts will just get erased. Like you won't have to think about these things. Oops. Okay. Since you won't have to think about these things, what happens is that your answer lies on a diagonal now. This is the intuition. Okay. Now, guys, if this much is clear, okay, let me just erase this much. Now, the second part comes into play. How do I have used one query up to now. Okay. Now, I have 3 queries left apart from the answer. Okay. Apart from the answer, I can still ask 3 questions.
Boris, can you repeat last point?
Which point?
Like how you eliminated the search space by one query. By your first
Because
query.
no. I asked one query, right? I asked the corner.
Okay.
If I ask the corner element, one query is gone, right? And I get this diagonal. Okay. Now, okay. No. Don't think about binary search or any algorithm, right, guys? Just think about it as a problem. If it is binary search, amazing. But now, guys, how did we get this diagonal? Because since we asked this query 1 comma 1, okay, and we got the answer, let's say, to be 3, then these are the elements which are at distance 3 from 1 comma 1, right? It's 4 comma 1, it is 1 comma 4, and these elements. Okay. Now, guys, we have 3 queries left. Okay. And we want to know where the mind exists. Right? Now, what can I do? One thing is for sure, I would like to query on somewhere on this diagonal. Yes or no, guys? Once you have the diagonal, the next query you would like to have this on this diagonal. Yes? Okay. So, if I query this particular element, right, what can happen? Either there is a mine over here, okay, and I get this distance, or I get the distance of the mine from this particular element. Yes or no, guys? Tell me. Yes? Whatever this is, let's say this is x comma y. If I query x comma y, I am going to get the distance, right? And now, since I got the distance, either it is going to be this element, okay, or it is the mine is going to lie here, right? Now,
Excuse me.
since yes,
Uh, you are saying that when we queried 1 comma 1, the mine could
yes,
be at four blue places, right?
yes.
For
Like
but
no,
for example,
it's a diagonal. It's not 4 places. It's a diagonal.
yeah,
It can
yeah, the one of the mine could be in one of these four
yes,
blue places, right? But for
yes.
example, you queried the down blue one. Will you number it?
Which one?
Uh, the down blue one, which is in the
Yes,
rectangle. If you
yes.
queried, if you queried this one, but there could also be possible that the mine is just under this one only, second
That's
mine.
exactly what I said, right? Like there are two possibilities. Either there is a mine here and you get returned the distance of this mine, which is minimum, right? And the second case is you get returned the distance of the mine which is on this diagonal. Yes or no?
Yes, sir.
Yes. You agree that the first query will give you this diagonal regardless. Okay.
Yes.
Okay. Now, guys, what can you do? Let's have a look. Okay. I got this query and I got this distance. Do you agree that since I know this distance, I know where the mine can possibly be? Yes or no, guys? Tell me. Yes. Okay. Since the mine, I know which element it can be on because I know the distance. So from this particular cell, since I'm going upwards, I will know what it is, right? Okay. So I can just query this particular element, whatever that element is, I'll just query it. Let's say it's x1, y1. Okay. If this returns 0, can we say we found the mine? Yes or no, guys? And if it does not return 0, I can say that that distance was for the other mine. Okay. Now, guys, tell me this. Okay. Now, if I got the mine, great. But if I did not get the mine, how I have used 2 queries. So I have 3 queries gone. in one query, how can I get the mine? And for this, we would need a little bit of mathematics. How? Let's have a look. We need a bit of proof making, right? And I'm going to prove it to you how we absolutely can get it, right? So, guys, like I'll give you a very intuitive proof. There is nothing to be scared about here. But let's say this is the spot I queried. I got this diagonal. Okay. Now, let's say one mine is over here. Okay. This is one mine and this is the other mine. Okay. If you look at these 2 points, do you agree that if for this particular diagonal, this mine is closer, then for this diagonal element, this mine is going to be the closer one? Yes or no, guys? Tell me. Like, can you think of a test case where for both these elements, this is the closer one? It's not possible, right? Yes or no, guys? Tell me. Is it possible? You can think about it. It's not, right? It's not. Okay. It's not possible. So, exactly. Now, if you have this particular proof in your mind, this is hard to come up with. Okay. This is hard to come up with. This is the part that actually makes the problem hard, right? If you can come up with this, okay, this is what we need to build, and that is what we are trying to build in this particular TL 11.0, right? This is the observation that we need to build, that for at least one of the corners, this mine is going to be the closer one. Okay. So, what, getting back to the problem, guys. Now, if I didn't get the mine, what can I do? I can just query this particular element, and whatever the distance is, let's say the distance is 1, 2, 3, 4. Let's say the distance is 4. I can just give the answer that this is the mine, and it is always going to hold true. Is this clear,
Gaurish, can
guys?
you repeat the last part again?
Which
Uh,
last part?
where the second mine was something, I guess, closer, right?
Right. So, to one of the diagonals, right? This mine, which is on the diagonal, is always going to be closer. Yes or no?
Yes, yes.
Okay. So, what can I do? I can get the, I can query both these elements. Okay. This diagonal and this diagonal. Let's say this returns D1 and this returns D2. Yes or no?
Yes.
Okay. So on this diagonal, I will just query, like this is D1, right? So what is the element which is at distance D1 on this diagonal? I will just query it. Let's say this is 1, this is something, right? 2. So I'll just query this. And let's say here I do not get 0. It means that this was not the mine, right? Because if I query that mine, it will give me 0. Yes or no?
Yeah. Yep.
So it by default means that this element is the mine, right?
Yes.
Because as we said, that for one of them, the element on the diagonal is going to be the closer one. Okay?
Gorish,
Yes.
how can you confirm that it is necessary that for one of the endpoints, the element of the diagram will be the closer one?
It's very simple, right? Like if you like, you can try to come up with a test case. Like what like let's say that for a particular element, both are on the same side. Okay, let's take that particular case. Um, okay, let's take the odd case. Yeah, let's take this particular diagonal. Okay. Now let's say our mine is over here. So from this, it is also distance 4, and from this is also distance 4. This is like the farthest possible minimum one, right? Now let's put the other mine somewhere and let's have a look what actually happens. Let's say I put a mine here. Then for this corner, it is distance 1. But for this corner, it is 1, 2, 3, 4, 5, 6, 7, 8. So I'm still able to get the answer. Now let's move it closer. Let's move it somewhere here. Okay. Now, if I want to get the answer, for this it is 1, 2, 3. Okay. And for this particular mine, let's move it. Let's see the distance. Right? 1, 2, 3, 4, 5. Still, I'm able to get the answer. Okay. So no matter what I do, this particular mine, okay, it's going to be closer to one of the elements because there is only one midpoint, right? Do you get that point? Like, no matter what I do, one is always going to be farther than the other.
The second mine cannot be above the diagonal because we are querying for 1 1.
You
So it must be below the
yes,
diagonal.
yes, of course, it must be below the diagonal. That is of course there, but yes, I think that makes it much more simpler as well. If it is below the diagonal, then no matter what you do, it is going to be farther away, right? Because it's just closer here. You get the point?
Yes.
Okay.
If it's the below the diagonal, say example 2 points below, I'd say
Here,
6, 0.
1, 2, 3.
Then
This right?
yes, at 6, 0,
Yes,
just below this one.
yes,
Then say example we query the uh we query this point 4, 0. Then it will say two
yes.
distance, right? And
It will say
the
one distance, right? Because
uh I meant ki like if the mine is at 6, 0.
this is 6. So okay, here. Okay, fine. Yeah.
Yeah. And then how will you like converge to then the other you'll ask the other possibility 0, 4 to check the distance, right?
Yes. Okay. Now, okay, let's take this example, right? I asked this particular element. I asked for this particular element, I got 2. And for it now on the diagonal, the answer is actually 4. Now, I will just check, okay, this, if it were true, if this distance was on the diagonal, then it means that this is the mine. Yes or no?
Correct, yeah.
So when I query this particular cell, do you agree that it would have returned 0?
Yes.
Okay. Now, since it does not return 0, I'll query this. It does not return 0. I will just query this particular diagonal element. And since it returns 4, I know that the mine, no matter what I do, lies over here.
Okay. Yes.
Okay. Great. So we used exactly 4 queries and we are able to come up with the solution. Is this clear for everyone, guys? If the idea is clear, let's move on to how we would solve it mathematically.
Sir, I'm not clear. Why are we querying all the four main corners? Like first one won't be sufficient for us.
We are not querying all mean corners. Who said we are querying all corners?
So, sir, if we're querying first corner and then
Yes,
all
wait.
the then we have a list of diagonals after first query, right? In the diagonals, we query another corner. So after that, we have the distance in distance. So we get answer in two queries, no? Because after second corner on the
No,
diagonal,
no, 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 no. That is the case. So there are two minds, right? Keep this in mind. You queried the first corner, you got that this diagonal is where it occurs. Okay. Now, when you query this particular corner, you are not sure that is it going to return the distance that is there from on this diagonal. Like if there is a mine over here, this would return one, right? But what if the mine is over here? How will you get the answer? Because you didn't get that data with you, right? That is true. Like if I have the answer, if I have the mine's location from here and the mine's location from here for that particular diagonal, I'll get the answer. But I am not sure if I'm getting that data in the first place when I'm querying these diagonals, right?
okay, got it. Thanks.
That is why we are querying this diagonal as well as this particular diagonal corner. And we know that one of them gives the actual data.
So basically, first choose any corner, we query on that, then we get a
Yes.
diagonal, then we query, let's say, on one of the endpoints, right? And
Yes.
then we get a distance. Now we might not be sure till now, right?
Yes.
So we
So you check on that particular distance.
distance. Then that one query, so three queries gone till now, right?
And
Then we
yes.
query the other corner of the diagonal.
Yes.
Yes, and this time we'll definitely get our answer. Either
Yes.
zero or not zero, right? So the other one becomes the mine location.
Exactly. Exactly.
But Gaurish's example, we get a odd distance from this one query. Then we can directly jump to the last one and do it in the three queries,
Yes.
right?
Exactly. I'm getting to that point. Exactly. Okay. So is the idea clear with everyone, guys? Tell me. Yes. Yes. Okay. Now, if the idea is clear, how do we go about solving this? Let's have a look. Like, how do you mathematically solve it? Okay. So, first of all, when you query 1 comma 1, okay, you get a particular value, right? You get x. But this is not a square. And that is what I want you all to notice, right? Since it is not a square, let's consider this is my grid. Do you agree that if I can get a diagonal like this as well when I query 1 comma 1? Yes or no, guys? So ideally what I want to know is, I want to know this point and I want to know this particular point. Okay. So when I want to know this particular point, right? So the thing is that since this distance is x, okay, my column would ideally be, if it were here, it would be 1 plus x. Yes or no? Like this column, this j part would be 1 plus x and this would be 1 comma 1 plus x, right? Now, if this 1 plus x is greater than m, do you agree it means that it is something like this? In that part, I just add 1 plus x minus m to this thing and I set this as m. Is this clear with everyone, guys? So how do I get this? Okay. First, I need to find x1, y1, and I need to find x2, y2. Okay. Now, how do I find x1, y1? So first, x1, I want to know this particular, right? This one. X1 is equal to minimum of 1 plus x, whatever the distance, 1 plus t, comma n. Yes or no, guys? Tell me. Yes. And now similarly, y1 is nothing but d minus x1. D minus x1 plus 1. Okay? Yes or no? Yes? Take some time to digest this. Now similarly for x2, y2, it is just the same thing. Y1 is equal to min 1 plus d comma m and x1 is equal to d minus y1 plus 1.
Gaurish, why didn't we put a condition in y1, d minus x1 plus 1, and let's say min of m? Like we take minimum of both.
Exactly. Because in this case, the dot lies outside the grid, right? So I want this particular corner, but it does not lie over here.
Okay.
So if you see here, the distance is 1, 2, 3, 4, 5. Okay. But here 6 is outside n. Yes or no?
Yes. Yes.
So 6 can be at most 4, like x coordinate. So that is 4. And now you had 2 remaining, right? Because the distance is 6.
Mhm.
So that would be 1 plus 2, which is 4 comma 3. And this is exactly this point.
Okay.
Yes or no?
Yes. Yes.
Okay. Now, similarly, once you have found this, you can find it for this corner as well. Yes, Parth. If there was only one mine, you could do it in 2 quizzes. Yes. Okay. Now, once you have got this diagonal, okay, you got these 2 points. Okay. What you can do, you can just query x1 comma y1 and you can query x2 comma y2. Yes or no, guys? And I'll get distance 1 and I will get distance 2. Right? Now, one more thing. Now I need to figure out if this is my x coordinate point, right? If I queried from here, I want to find where is that particular point. Okay. Now, guys, how do I query this? Let's have a look. Okay. Let's say here is my diagonal. 1 second. Now, what is the distance of this point from the diagonal, guys? 2. Okay. What is the distance of this point? 4. What is the distance of this point? 6. What is the distance of this point? 8. So do you agree that first of all, to find these points, the distance has to be even. Otherwise, I can already say it does not lie on the point. Okay. Now, if I get an even distance, how do I query it? Exactly. It is just x minus d2 and y plus d2. Yes or no, guys? If I want to query this cell, and let's say this is 5, 5. What is this? This is 4, 6. This is 3, 7. This is 2, 8. This is 1, 9. So if I want to query this, it is just 5 minus 2 and 5 plus 2. Krish says, why does the distance need to be even? Because I'm going 1 up and 1 right. So I'm adding plus 2. So I know that this first diagonal element is going to be even. Now, since this is even, how much distance is this point from this point? Again, plus 1, plus 1. So the distances keep increasing by 2. So since the distances keep increasing by 2, it's an even. It's always even. I hope you get that point. Get my point, right? Yes? Okay. So guys, this is all that you have to do. Okay. What is basically the code? You query one.
Gaurish?
Yes.
Yeah, in this matrix, like if we factor in the second mine as well, so at some point, like it will be always larger than the another diagonal end, and it will be like always it's and then some at some point both of these diagonal ends will point to the middle element, right? The one on the diagonal, the mine on the diagonal, right?
What do you mean by that?
Say example, there is another mine.
Yes.
Then if it's very closer, and
Let's say here.
it will always will be like below only, right? Diagonal.
Yeah, sorry. Let's say it's here.
Yeah. So I'm saying ki like it's intuitive, right? Ki like one of the diagonals will always be farther than it, and at some point both will be so much farther that they will both start pointing to their Manhattan distance will reflect their mine on the diagonal, right?
One of them would reflect on the diagonal one. Yes.
Yeah, and if this
At
point
least.
goes such further distance away that at some threshold it will start reflecting the point on the diagonal, right? Mine on the diagonal.
Yes. Like after a point, both will reflect the mine on the diagonal. But no matter what the case, at least one of them is going to reflect the mine on the diagonal.
Correct. Yeah. Yes. Yeah.
Okay. So guys, what is the code? First of all, you query 1, 1. Okay, you get the distance d, right? Once you get that distance d, you want x1, y1 and you want x2, y2. Okay. How do you get this? So first of all, x1 is equal to min n, 1 plus d. And then y1 is equal to d minus x1 plus 1. Similarly, here y2 is equal to min of m, 1 plus d. And here x2 is equal to d minus y2 plus 1. Is this clear for everyone, guys? Okay. If this is clear, then you query both. You query x1, y1, okay? And then you query x2, y2. Okay. After that, once you have done this, you will get both distances. You will get D1 and you will get D2. Okay. Now you need to check for one of them. It does not matter which one you check. Let's check for this one. Okay. So in this particular case, first of all, D1 has to be even. Only then it is possible. If D1 is not even, you can just declare this as the winner. Okay. So if D1 is even, what will you query? You will query x1 minus d by 2 and y1 plus d by 2. Yes or no, guys? If you get 0, you can say that this is my mine. Otherwise, now I have to solve for this, guys. I have got an even value here. How will I get this? This is x2 comma y2. What is the coordinate of the mine? Tell me. This should be very simple. Again, it's just the opposite of the previous one. If I have got x2, y2 and I've got d, yes, amazing. So it is just x2 plus d by 2 and y2 minus d by 2. Is this clear for everyone, guys? Tell me. Yes or no? Okay, amazing.
Sir, can you
So
please repeat for Y1 case? And
what do you want me to repeat?
sir, for case 1 where we are finding Y1 value.
Sure, right?
Yes, sir.
So one thing is that you got your x coordinate, right?
Yes, sir.
Using this. Now we need to get the y coordinate as well. Yes or no?
Yes, sir.
So since x1 is on this line, it's going to be something, right? It's going to be greater than this value. Now, this distance, okay, x1 minus 1 plus whatever distance the y is away plus whatever this distance is equal to the distance that I got as my query, right?
Yes, sir. Got it.
And what is this? This is y1 minus 1. Yes or no?
Yes, sir.
Okay. So then you can just use this to find the answer. Yes or yes?
Gorish,
Yes.
can you repeat that point? That one of the mines that is really closer to the points will always be on a diagonal. I also tried to solve it on pen paper, but I can't understand.
What I'm trying to say is that no matter what you do, okay, let me just go through this very
Suppose there are
quickly.
two endpoints on a diagonal, and you claim that one of the mines that will be closer will always be on the diagonal mine.
Yes. So one mine is on the diagonal. Yes or no?
Yes.
Okay.
Another mine is
Now,
below the diagonal.
yes, another mine is below the diagonal.
So
Can
I
you come
can't
up with
I can't
so
understand that why one mine. It is always possible that if we query at the two end corner points of the diagonal, we
okay,
will at least get the
okay.
mine
So
on the diagonal.
we want that. So what do we want? We want that for both these places, the other mine is closer, right?
Yes, yes,
So ideally, we would want the other mine to be in this diagonal because this diagonal is the closest one. Like, right? Like
yes, yes.
this is distance 1, this is distance 1, so on and so forth.
Okay, okay,
Okay.
okay.
But no matter what you do, since this diagonal is farther away from this diagonal, okay,
Yes,
do you see that no matter where I place it, if it's closer to one point, it is going to be farther away from the other point, right? It's because those points are fixed.
Yes,
Think
yes,
about it like this, right? Think that you have a line like this, okay?
yes, yes,
You have a straight line,
yes,
okay? And there is a point which is on this line, okay? How will you place another point on this line, okay, that is not on this line, such that it is closer than to both points than this point? It is not possible, right? Because you can see that it increases the distance at least one place. Like if you move it here, you can see that this might be closer than this point, but then here it is not closer, right?
okay,
Are you able to visualize it?
yes, yes.
Okay, so
This example I have
that
utilized.
is basically the idea. If you visualize a straight line and then that mine is on that straight line, then that is exactly what we need to do. Okay, if
Okay,
this much
okay.
is clear, guys, this is uh this is all that is there to the implementation. If it is not there, like if this is not 0, then what do we print? We print x2 plus d2 by 2 and y2 minus d2 by 2. Is this solution clear to everyone, guys? Yes. Like what I tried to explain to you guys is using Python here. Okay. Now, if this is clear with everyone, let's move to the last problem. And this is also a kind of interesting problem. This is, again, it's a standard problem. This shouldn't be so hard. But do you get my point, guys? Why did I pick these problems today? To show you all that interactive problems are just normal problems. Like you don't need to do anything extra apart from your query function. Like there's a bit of change in the implementation, but the ideas that you need to bring up are just ideas that you need to bring up in any problem as such. Okay. Like, of course, you don't have pre-tests that are given to you. Guessing the greatest hard version is there in the practice problems. Are you sure?
Easy version is there.
Easy
Hard
version is there,
version.
right?
Hard
Hard
version is
version. Okay. Hard version is not there. Okay. In easy version, how do you solve this? Tell me. How many queries are there? 40. Okay. Okay. Let me share the link. So great. Since it is practice problems, you guys already have an idea. Now let's see how do we do it in 20 queries. Okay. So what does the problem say? You are given an array and there are n different numbers. Okay. Keep this in mind. Everything that is given in the problem statement is important. Every number is different. In one query, you can ask the position of the second maximum element in a subsegment. Okay. Find the position of the maximum element in the array in no more than 20 queries, right? We can share, you can share it later, right? Let everyone think and then we can discuss the solution. So in one query, what can you do? You can query a range, and then in that range, basically when you query L comma R, okay, you will get the index of the second maximum. Okay. And again, if you have not come across this particular problem, try to apply first principle thinking. What I'm trying to say is just try to observe things that are there in the array. Once you make some particular observations, then the problem becomes much simpler. Okay. So think about this. It's 3 6. We'll discuss the solution at 3:10 p.m. Okay. Let's wait for 5 minutes, then we can see. Okay, guys, let's discuss the solution. Uh, right. Okay. So, guys, no, we can't do it. No, no. We can do it in 20. We have to do it in 20 queries. Okay, Sakshi, not 3 queries. We can do it in 20 queries. Okay. No, no, not exactly 20 queries. You can do it in less than 20 queries. You can do it in no more than 20 queries. Okay. And n is smaller than equal to 10 raised to 5. Yes. Yes. Okay. So, guys, what does the problem say and how we can solve it in 20 queries? Okay. Now, guys, we are given an array where all elements are distinct. Okay. Let's consider the array is 10, 1, 2, 3, 5, 7, and let's say 8, 7, and 6. Okay. Now, the first thing to notice is that we would want to know what is the second largest element in the array, right? Because if we get the third largest or fourth largest, how isn't it harder to think about a solution? Like, let's say we query the entire array. What do we get, guys? Do you agree we get the second largest element?
Sir, I have an approach that I got it. Can I just,
Sure, sure.
sir, what I'll do is, so I'll have a left pointer at the 0 and right pointer at the 6. I mean, at the last. So for the first query, I'll get the second largest element, which is 8.
Yes.
So, assuming I'll take the right pointer to the 8 and left will remain at the 0 index itself.
Yes.
So, what I'll do is again, I'll query that what's the second largest element. So, if it's again showing me 8, so I'm quite sure that It's in the left segment itself.
Okay.
So like that, sir. Like
No, but for example, if you query this and then you get this 8 again,
yes, sir.
what are you going to point where?
That the maximum element is a left segment as well.
No, but then how will you now you have your left and right pointer here. How are you going to make changes?
Okay. Yes, sir.
Gorish,
That's
regarding this,
yeah.
I have one approach maybe.
Okay.
So let's say first query is same 1 to n we do. We
Okay.
get the second largest number, and let's say it is found at an index idx.
Okay.
Then I query both the sides
Okay.
from like left to idx minus 1 and from idx plus to the last upper.
Okay.
In that case, at one point I should get a number which is greater than the first query, right?
You won't get a number which is greater than the first query, right? Like if this is the second largest element, you can't get a number which is larger than the second largest element, right? You'll
No,
either get a smaller element or the same element.
no. So that's why so next time when I query, I'm not including 8. I'm just moving a pointer to one side, like both the sides, like minus 1 and plus 1.
Yeah,
Yes.
you'll still get a number which is smaller than 8, right? No matter what you do, the query that you will get is always smaller than 8.
But the query is going to give me the second largest, isn't
Yes,
it?
the second largest of these subarrays will
Yes.
never be larger than the second largest element of the entire array. Yes or no? Like even if you query here, you will get 5 and here you'll get 7. There is no chance this 5 and 7 can be larger than 8 any day.
Yes, yes.
Yes. Okay. So guys,
So I,
Say example, Gaurish, if we get second largest at X index and we query one side, if we ask
yes,
query at one side, it will say example, if X is the index, we ask query at from one side of X to the to the one end, and
yes.
if we don't find it, we do the reverse. Like it should.
when Gorish, I had something in mind.
Okay.
So suppose my first pointer is at 10 and
Okay.
I query for the whole and I get 8. Okay. And then my pointer would be pointing, my left would be pointing to 10 and right would be at 8. So I know that
Okay.
second largest element is 8. Now what I'll do
Yes.
is I'll take my right as right minus 1 index. Okay. So
What would you do?
I know the second largest element is 8. So what I'll do is I'll reduce the search space by the right index would be r minus 1. Okay.
It would
Because
be
I know
here.
that, yeah, 5.
Okay.
Because I know that my answer is on left side, right?
Okay.
So the position of the second largest element minus 1, I would be reducing every time if it's on the left side. And if it's on the right side, I'll be doing the position plus 1. So in that manner, I was thinking something of L would
Okay.
be
Yes.
position plus 1 and R would be position minus 1. Because I
Yes.
didn't
You
do
are
that.
very close to the answer. So that is what we'll exactly discuss. Let's discuss the solution, guys. Okay. You are very close. That's more or less it. So first of all,
Yeah.
guys, do you agree that if we query the second largest, if we query the entire array, which is 0 to n minus 1 or 1 to n, whatever is expected, we'll get the second largest element of the array? Yes or no, guys? Tell me. Put a yes in the chat if that is true. Okay. Now, guys, let's, okay, this is my I. Now, my max element either lies on the left hand side or on the right hand side, right? This is my second largest element. How will we come to know if it lies on the left hand side or the right hand side? Tell me, guys. How will we come to know?
So from 0, we can check up to I, 0th position. And then another check is I to N, like the last position. And like wherever
Exactly.
the same second last element is there, so that side the maximum element is there.
Exactly. So we'll just query these two sides. Okay. Now, guys, do you agree that the side which contains the max element is again going to return I, and the side which does not contain the max element won't return I? Yes or no, guys? After this, we'll come to know which range is it that contains the second largest and largest element. Okay. Yes, only one query is required to tell you which side it is required. Now I will solve it. Yes, all elements are distinct. That's given in the question, right? Okay. That was very important as well. Now, guys, let's say it is there on the right hand side. Okay. I've got my I have got my n minus 1. Okay. Now, guys, your maximum lies somewhere in the array. We need to find this index. And now this problem should not be that hard, because using some query L comma R, I need to find, like this returns the second largest, right? I need to find what is the index that contains the max element. Now, guys, do you agree that if I query this I to any index after this, okay, if I query this I to any index after the index where max is, it would return me I itself. And for, like, when I query this I comma j, right, where I is the second largest element. Now, for all other indices where I query I comma j, it would give me something else which is not I. So isn't this a monotonic function?
Can you
That
please
is
explain this last point, what you just said?
okay. So when I, like, let's say I queries I, which is the second largest element, to j. J is some random index. Now the thing is that either j is greater than equal to the index where the max element is, or it's before the max element. Yes or no? If it is greater than equal to where the max element is there, it would just return I, right? Which is the second largest element.
Yes, yes, yes.
But now, if it is not, the max element is not there, it would return me some other index, which is k. Yes or no? Because it would give me some other element, right? Because no other element can be greater than I, than x, like
Okay.
ARRI.
Okay, I got
Okay.
it.
So this basically right here is a monotonic function. Like till a point, I'm getting some random answers, and after a point, I'm just getting I. So our task is to find this index after which we get I. So do you agree that this can be just solved using binary search? Yes or no, guys? Yes or no? Wasn't this relatively simple? It's just a standard binary search idea. So what do? You find the second largest element, okay? Then you query which side your max element is on. Now, depending upon which side your max element is on, you would like to write a different binary search, either here or either here, right? Now, depending upon that, like if I get it for right hand side, I'm sure you guys understand how to solve it for the left hand side as well. So the max element is somewhere. You just need to find the index where it is. So I will just query index I and j, and I want to find the first index j such that I return I as the answer. Now this can just be done using binary searching on index, right? Binary searching on j. Now, what is the time complexity of this? This is big O of log n. And since n is smaller than equal to 10 raised to 5, I will use around 17 queries here. And I used one query for the entire array and two queries for left and right. So 17 plus 3, which is 20, worst case, which fits into our constraints. Yes or no, guys? Was this hard? As we are not dividing array to, how is it log base 2? And it is, right? Harshvardhan, if you look at it. So let's say worst case, your max element, second last element is here. It is, right? Can you clarify in case where you get, will it not require inquiries? No. So let's take the example that Harshvardhan suggests, okay? Which is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now I will query L to R, which is 1 to N. And I will get the second largest element. Do you agree that this took one query? Yes. Now I will query this entire array, and because there is no right hand side, this left hand side. And it again returns me this index. It took me one query. And let's say it confirmed that it is on the left hand side. Okay. Now I just need to find the index of 10. So do you agree I can just binary search on it? So I query this range. Okay. I get the answer as something. I get the answer as this. So I know that for any index here, it is not valid. Then I move on to this range. And for this particular range, I will query the mid element. So I queried this much. And you can see that answer I got again is 8. So for this entire range also, it is not valid. So what do I do in the end? I query this entire range. And since I get I back, which is n, I can say that this 0 or 1, whatever, based on what base indexing it is, I can say that this was the index of my max element. Yes or no, guys? This was not n queries, this was log n queries, right? No. We are, right? We are using 9. We will be always querying 9 to that particular index. Okay. So guys, do you understand how we use binary search? And this is not so hard as the previous problem, because if you have solved enough binary search problems, you will be able to come up with this solution without much thinking, right? Because this was just a standard binary search problem. Now, how would we implement this? Let's have a look. Okay. So let me show you the code for this particular problem. Now you can see that I have written a query, and I am basically have written two different binary searches. One in which the max element is on the left hand side, and one in which the max element is on the right hand side, because the binary search differs, right? In the left element, if I get the answer, I would be moving towards the left. And on the right side, if I get the answer, I'd be moving backwards. Okay. So the answer changes. So what do I do, guys? I query my pivot which is my second largest element, I query 1 to n. After that, if pivot is 1, then I will just print out the answer of right of pivot plus 1 to n. Basically, what I'm saying that my max element range is between whatever the index of the second last element was plus 1 up to n. Otherwise, if query of 1 to pivot is equal to pivot, it means that my largest element lies on the left hand side. It's exactly what we discussed. So in that case, my answer would lie in 1 to pivot minus 1. And that would be a left binary search. That is a different binary search, right? And otherwise, again, my pivot is pivot plus 1 to n. Okay. If this much is clear, let's move on to the binary search part. The binary search part is very clear that I store the second largest element for left. Since my pivot is at r plus 1, I'll just store it. Okay, my second last element is at r plus 1. And my answer is initially L. While L is smaller than equal to R, mid is L plus R equal to 2. If query of mid to pivot is equal to pivot, then answer is mid, L is mid plus 1, otherwise R is equal to mid minus 1. In the end, I just return answer. The only thing I change is here I would do, instead of here I'm doing R is equal to, here I'm doing L is equal to mid plus 1 for left side. For right hand side, I would do R is equal to mid minus 1. Because when I get an answer for my right hand side, I would be shrinking my search space like this. But in my left hand side, I would be shrinking my search space like this. Okay. Is this clear for everyone, guys? Okay. Is our interactive problems that intimidating now, guys? Tell me. Like, is it something different? Why is it 1900? Even I don't know. Okay. So the thing is that we solve problems today using very simple basic principles. And that is what I want to convey to you people. Don't try to force algorithms into problems. Just look at basic observations of the problems and try to deduce how would you solve the problem, and then you will come to know, okay, now to solve this part of the problem, I can use this particular algorithm. Now, if you use this kind of approach, then one, you would be building your problem solving skills, and then problem just become intuitive, like how I just explained right now. Kushal says, why do we need left and right? Because we will be binary searching on it, right? You would be binary searching on the index, Kushal. So that is why we need a left and right search space. Yes or no? Okay. So Kushal says, why two separate functions? Very simple. Let me just explain that. Okay. Why two separate functions are needed? Because either this is I and the max element lies on the left hand side. Okay. Or this is I. Okay. And this lies on the right hand side. Do you agree that right now, if I want to binary search on the left hand side, my logic is different. Like if I get I would be moving towards the right hand side. Okay, I would be decreasing my search space like this. But if my max element lies on the right hand side, once I query here and I get that, okay, my second last element is I, then I would be shrinking my search space like this. That is why it differs, right? The logic is same. You want to binary search, but since it is on two different sides, you would require two different binary search functions, right? Either on the left one or the right one. Yes or no? Okay. So, okay, guys, that is more or less it. We would be looking at some particular problems, right? And yeah, will we be solving more problems today? No, I just took 3 problems, 3 very good problems that each teach you something and more or less give you the idea that interactive problems are just normal problems, but you just need to print, you just need to get input from the online judge. Nothing to get intimidated about, right? Just normal things, apply logic and get them solved. I hope you liked today's session. We'd be meeting again tomorrow. Do let me know if you have any suggestions for these problems. What is which rating to solve in interactive problem? You can just sort by rating and solve one by one if you want to get good at interactive problems. Like for example, this particular problem right here, this is like 1900. Okay, but there is no reason for this to be 1900. Okay, so just do that and meet you guys next time. Till then, bye bye. Let me just stop recording. Okay.
The recording has stopped.
Okay, amazing. So great. I have covered that in the post contest discussion, Nevedyam. You can have a look at that. I have exactly used. Yes, I will share that as well, Mohit. I'll share it by tonight. I have another class in some time. Okay.